Ramsey.
Thank you, Angela. As a reminder to everyone that's joining us this evening via Zoom, if you have questions as Gordon goes through his presentation, if you would submit those in the chat window of Zoom, and then at the end, when we're taking questions both there from the members at the Hilton, we will also take questions from the chat window as well. Our speaker is Emeritus Professor of Physics at Loyola University, Chicago, where he has been for 40 years. I think Gordon would tell you he started working there when he was age 10. He received a BA in Physics and Mathematics from Southern Illinois University and MS and PhD degrees in Physics from Illinois Institute of Technology. His interest in the Civil War dates back to high school. His junior thesis was on the economic causes of the Civil War, and Gordon loves to apply his passion for physics to historical topics. As an Air Force veteran, he has an interest in air warfare, and tonight he will combine physics and air warfare to discuss for us ballooning in the Civil War, how the Air Force really began. Please welcome Gordon Ramsey.
Thank you. Thank you very much. First of all, I'd like to thank Michael for inviting me to give this talk. I always enjoy giving these talks to the Civil War roundtables around the whole area. And this is really a pleasure. I'd love to be there with you, but traveling in the wintertime in Chicago is not the most fun thing in the world. So let me go ahead and get started with a disclaimer. This is not a talk about the following things, about a general or politician, any particular battle of the Civil War, not about soldiers or weaponry. It's not really about a success story, but neither a failure, and I'll talk about that. And it's not the effect of the war on civilians. It's also not a talk on Illinois or Georgia's involvement in the war itself. It's more broad. So what it is, let's see. Here we go. What it will be a talk about is Civil War first. Some you may have not heard about. The history of balloons, and this kind of gives you an indication of why the Civil War was really appropriate for the first use, real use of balloons in warfare. I'll talk a little bit about how balloons work, because this will give you insight as to why it was difficult to man a balloon corps during any kind of war. I'll talk about the military use of the air, which leads to the humble beginnings of the Air Force itself because of the lessons they learned from the Civil War. Talk about human conflict and politics and bureaucracy, and that will explain why the balloon corps didn't last throughout the Civil War. And, well, maybe not suspense and intrigue, but I hope you'll at least be intrigued about the topic itself. So the outline is, I'll talk a little bit about the history of balloons, when they were developed, about how they work and their complexity, a little bit about pre-Civil War ballooning and what led up to the real technology in being able to use balloons on a wide scale. I'll talk a little bit about the battles that balloons were used in, some of the successes and failures, certainly the political structures and the bureaucracy, and of course the aftermath, which is the lessons we learned and how it evolved eventually into today's Air Force. So the basic idea behind hot air balloons has been around for a very long time. Archimedes is the one that discovered the principle of buoyancy and might have even conceived the flying machines because of that. There's no evidence to show that the story or the myth that he ran out from the bathtub naked and ran out in the street with his discovery, that doesn't seem to be true. But nevertheless, it's been very important. And his discovery, although it was in water, is true for any fluids. It took till the 13th century for Roger Bacon and Albertus Magnus to propose some sort of a hypothetical flying machine. And as we know, during following centuries, Da Vinci tried to develop a flying machine. But it took until 1783 for the Montgolfier brothers in Annonay, France, to really develop a balloon that was workable. And if you don't know where Annonay is, it's in the southeast corner of France, where the mountain has mountains by it, and it's right on the edge of the mountains. So it's a really nice place to have ballooning. So on June 5th of that year, they flew an 11-meter diameter hot air balloon. Now I'm going to use the metric system, but I'll try to translate into the system that we use here. I am a scientist, so my mind thinks in metric. But 11 meters is about 35 feet. So you can kind of picture that. It was didn't have any inhabitants to it, just a regular balloon flight. In 10 minutes, it was about 2 kilometers long, which is a little over a mile in there, and 2 kilometers high. It was a fabric balloon lined with white paper coated with alum for fire retardation. It was hot air, so they didn't want it to catch fire. And apparently it worked. So this was the first working model of a balloon in any kind of history. By September, they sent a sheep, a rooster, and a duck up for 8 minutes. It was in front of King Louis XVI and Marie Antoinette when they were still around in Versailles. It was designed by Francois de Rosier, who was a physicist from Metz, France. Metz is in the eastern part of France, and a member of the Academy of Sciences. So it took some science and engineering in order to get the balloons to really go. This is kind of an artist rendering of the Montgolfier balloon. Notice the crowds there, but that's not surprising since this was something totally different. The first manned flight was October of that year, where de Rosier reached a height of 28 meters. This is about 90 feet, 80 to 90 feet, but he was tethered by a cable, so it was fixed so it wouldn't fly away. But by November of that year, de Rosier and Marquet de Land flew in free flight. It was about 900 meters in height, so it's about 3,000 feet, 8 kilometers distance, about 5 miles, and of 25-minute duration. So this was the first manned flight of a balloon. By the summer of '83, Jacques Charles, once again a scientist, he was mostly a chemist, but he did physics as well, indicated for gases that the volume is proportional to the temperature. That was Charles' law, and he developed the first hydrogen balloon. Just a little physics here. As the temperature goes up, the molecules move faster, they take up more volume, and so it decreases the density. So what he did cleverly is to create hydrogen with a chemical mixture of iron and sulfuric acid, and I have the chemical formula down there. So that combines to give you iron sulfate and hydrogen gas. So he was able to fill up a balloon with that, a small balloon, and the first manned untethered hydrogen balloon flight was in Paris on December 1st of that year. So they were about 600 meters, about 2,000 feet, and drifted about 25 miles from the city itself. So this was quick development of the balloon. This is just a picture of Jacques Charles, physics and chemistry, who developed Charles' law. And here's again an artist rendering of the hydrogen balloon with a payload there of about 2 people. And I'll talk about the details of that technology in a minute. So the silk balloon, first unmanned flight of a silk balloon, was the globe from Paris to Metz, France, about 15 miles. And Ben Franklin was actually there negotiating a treaty from the Revolutionary War that France was helping to negotiate. So he actually saw one of the first unmanned flight of a silk balloon in Paris. De Rosier and Pierre Romain were the first to die in a balloon flight 2 years later. It was a hydrogen balloon, and unfortunately, hydrogen is highly flammable. So it did flame up, and of course, they perished in the process. This kind of dampened the balloon mania, but not for long. It took a while, but first military usage was actually in the French army for reconnaissance. But Napoleon wasn't excited about it due to the lack of view, due to heavy gunfire, the smoke and everything got in the way. And of course, occasionally dropped messages and so forth into enemy hands. So he didn't want to take that chance. So at the time, though, balloons were not really reliable as they were toward the Civil War. Here's the Blanchard concept of a balloon shaped like a bird. Uh, and, so they had all kinds of designs and everything for payloads on that. So let me talk a little bit about how balloons work, because that gives you insight as the complexity of being able to man balloons for reconnaissance and so forth. Some of the advantages of balloons, of course, are the long range view. And my next slide has an indication of how effective that is. They typically cannot be reached by gunfire. They're fairly small, and as high as they usually go, it's a very small angle to aim at, even for artillery. And remember, the balloon is always moving, if it was just moving back and forth. So you have a moving target that's less than 1 degree of an angular target, so it's not going to get hit, likely not. They can travel a long range in principle. And of course, they're all terrain because once you get up there, the mountains don't get in the way. Disadvantages, of course, are they're very susceptible to weather, especially rain, high winds, and so forth. The weather, the lightning could be a problem, and so forth. They can't be guided effectively, except for the most trained balloonist. The Civil War versions were not highly reliable like they are today, but much more so than they were during the early 1800s. They do need a lot of gas that's not readily available. They have to be manufactured, the gas, or available somewhere. And of course, the success depends on the weather, the country, the proximity to the enemy. But nevertheless, they have been effective. Here's a little bit of this is a calculation I did, just purely geometrical. How far can you see, given the curvature of the Earth, given the balloon height? And I'll take the 500 meters. That's about 1,600 feet, which isn't very high. It's really only about an 18-story building, for example. So it's not really high, but you can see 50 miles. So it's very effective. At 1,000, to double that, you can see 70 miles. So there's quite a bit of advantage to having that height and being able to see things, as long as it's clear. This is kind of a rendering or a picture of a balloon view over DC in 1861, and I'll talk about this specific launch in a few minutes. And you can see the Potomac and so forth in the mountains in the distance, but you can see quite far. This one's only maybe a couple hundred meters high, so it's not very high, and you can still see quite far. So let me talk about a little bit about how they work. Again, the Archimedes principle, a buoyant force in an object in a fluid is equal to the weight of the fluid displaced. Well, let me translate that into English. An object less dense than the fluid floats. If it's more dense, it sinks. If it's equal, they just kind of hover there. So the idea is to get the balloon, air in the balloon, or whatever gas you use, to be at least dense as possible. So there are two ways to do that. Use a lighter gas to fill it, and hydrogen and helium are the obvious ones, because they're the lightest gases you can get. Or you can heat the gas. So you can heat air, and the faster moving molecules, of course, by Charles' law, will increase the volume, decrease the density, and hence it will float. So let me give you some figures on that. Don't worry, I won't quiz you on this, but just some figures. A cubic foot of air has a mass of about 28 grams at a room temperature and 7 grams less when heated. So you can figure about 25% less dense when you heat it only to 100 Fahrenheit, which is not even, what's necessary, not even boiling. So 1 cubic feet of air, so to give you a figure, can lift about 7 grams at this temperature. Bottom line, to lift 1,000 pounds, you need about a 65,000 cubic foot of air in the balloon. Now, typical person, maybe a couple hundred pounds, so you'd only need a small fraction of that, which actually worked. And typical balloons in the Civil War were between 15,000 and 64,000 cubic feet. 32 was probably about the max that was ever typically used. Now, hydrogen and helium do weigh much less than air, so they provide much greater lift. However, hydrogen is volatile, and helium is very hard to find and hard to produce because it's stable. So hydrogen, you don't want to expose it to a spark because disaster could occur. So gas balloons can be filled with hydrogen if you're careful about it. Helium or natural gas, even, which they used in a few of the balloons. Coal gas is another one. And helium, of course, is the safest, but not readily available. Natural gas is probably the cheapest way to go. Here's a little diagram of a balloon just to give you an idea of the parts. On the lower end, you've got the propane tanks, and you've got the burners here. This is a hot air balloon, obviously, and the valve cord. The parachute valve is up on the top, and that opens to let air out of the balloon so you can sink and decrease your height. And of course, this is separated into panels. That's how it's constructed. Each sewn together, so they make the full balloon, the envelope of the balloon. So that's what it looks like. So how do we fill a balloon? The hot air. Okay, what do? You put the balloon in the direction of the downwind so that it fills it up just a little bit, and it forces air into the bag. And when it's partially filled, the burner is turned on. So you turn a burner on, and as the air heats, the bag will rise, and eventually you get it filled and hot enough. And of course, then you can take off. Now, during the flight, the air is going to get cooler inside because of the difference in height. It gets colder up there when you're very high, but you can turn the burners on. It'll rejuvenate the thing. Now, for a gas balloon, the top is centered over the bottom, and the fabric is spread out evenly, so it fills up evenly. And of course, the gas itself will inflate the bag, and the ballast is placed in the balloon to regulate the ascent. And of course, they're usually tethered to begin with, and I'll show you a picture of that. Here's a picture of that. If you can see, right along the sides here, there are tethers, and that's to keep it down on the ground while it's filling up until it's ready to launch, and then the crew down below lets it go. So that's how they are filled. When you finally fill them up and start flying, the only controls you really have are the heat to make the balloon rise and venting to make it sink. And then it takes an experienced pilot because they can maneuver by changing the height, since typically air currents go one direction when you're lower and the other direction when you're higher. So you can maneuver your displacement by actually maneuvering the height. And of course, then you ride with the wind. And the wind speed does increase as you get higher, so that has to be taken into account. So this is why it requires a trained pilot in order to do this. This message comes in later when we talk about the balloon core. There's a modern balloon having taken off and ready to go. Now, piloting is largely improvised, but it can be very safe and so forth with a cautious pilot. And the weather has to be ideal, of course. You have potential lightning strikes during rain. You also have possible damage to the balloon itself, the envelope. So you have to have almost perfect wind and perfect weather. The ripcord was invented by John Wise. His name comes up later. That's what lets the air out, and the rip panel. And this was not until 1839. So you're beginning to see the history and how it develops into the Civil War balloons. When you land a balloon, the pilot then has to let some of the air out, decrease the height, find an open space where there are no trees and power lines. Those really play havoc on a balloon. And of course, plenty of room to lay it out and provide the landing. The experienced pilot then lowers it as low as possible and will bump along the ground just a little bit to stop the balloon gradually, because friction takes over and eventually it stops, and the ground crew will then hold the basket down once it's landed, and then, of course, you're home free, so to speak. So let me talk about pre-Civil War ballooning, because that really leads up to the Civil War and talks about the technology of what led up to being able to use the balloons on a large scale. So Franklin, having seen the balloons, suggested that 5,000 balloons, each capable of raising two men, could repel an attacking force. Well, 5,000 balloons isn't very practical, so that really didn't work. Meanwhile, in France, Denmark, Russia, and Austria, they used balloons to observe enemy positions, but extremely limited success due to their unreliability. So they weren't really used on a large scale until the technology allowed it. So from 1834 to 40, the technical developments in both Britain and the US allowed the large scale ballooning. So let's talk a little bit about that. Some of these names will come in later. Charles Green of Great Britain invented the guide rope for guidance, a little bit of friction for more control of landings. So this enabled at least some safe landings. He made a very long trip at the time. This was about 1835, from Great Britain to the Netherlands, and which is about 373 miles. Took him 18 hours. If you look at a map, even though you think the Netherlands are a little bit south, it's almost straight east of Great Britain. So it was a fairly easy flight. He could follow the eastern winds up high. So it was fairly easy, but it took him 18 hours. But he actually made it safely. John Wise, who invented the ripcord, performed atmospheric studies. He studied the atmosphere for wind currents, navigational techniques, and he developed actually a balloon that used cotton and bird lime soaked in linseed oil. His balloon was about 28 feet in diameter. It was a 13,000 cubic foot balloon. So this was enough probably for two light people to ascend and so forth. Another gentleman from the US, William Paullin, whose name comes up later, experimented with gases and developed a coal gas, which is a sulfur-based gas that's less volatile than hydrogen. It was kind of hard to manufacture, but you could do it as long as you're near a city. During the Seminole War, this was during that period, they suggested that balloons could observe Seminole positions, but they decided that the terrain was not available for their use at that time, so they didn't use them there. During the Mexican War, John Wise suggested that a place near Veracruz could be bombed using a tethered balloon, but they never pursued that idea, primarily for safety reasons. Wise was unsuccessful in raising funds for a large balloon corps, but he created a hoax story. Apparently, Edgar Allan Poe was involved in this, telling of a transatlantic flight from Europe to the US. And of course, that stirred interest. And Stephen Douglas of local fame presented the case to Congress, but to no avail. They really weren't excited about this. They figured, well, we don't know, it's not tested, and so forth. But he did write a book on the system of aeronautics that talked about all the studies he had done, and flew a balloon from St. Louis to New York in 1859. So this was just prior to the Civil War. So by that time, the technology had been established enough that you could have some balloon flights that were a little bit longer. Okay, enter the main character, Thaddeus Sobieski Konstantin Lowe. He was born in 1832 in New Hampshire, and he loved watching flying things like kites. And he was very inspired by Wise's book, The System of Aeronautics, when he was a young lad, probably about 10 years old. So he studied the physics of balloons, the strengths, limitations, the engineering aspects of it, the atmosphere, pressure and temperature at high altitudes, the role of a jet stream. And he figured that they already measured that the pressure drops to half its value in about 4 miles. So typically at 10,000 meters or 11,000 is when international flights fly. So this is about half of that, a little over half of that. And the pressure drops quite low at high altitudes like that. But also the jet streams change direction. So this allowed a little bit of flexibility in steering. Wise and Lowe are going to race to see who could cross the Atlantic. However, you can see in 1859, just before the Civil War, the war actually intervened. This is a picture on the top of Thaddeus Sobieski Konstantin Low. This was taken when he was 27, so he's a fairly young lad there. On the bottom is John Wise, a picture during the 1840s, and he was already, about his 30s then. So he was quite a bit older than Low himself. Enter another physicist, Joseph Henry, who did a lot of work in electromagnetics, but he was a very prolific physicist, lived from 1797 to 1878. In the spring of 1861, after Low had a successful flight from Philadelphia to New York, he wanted Low to take a test flight from Cincinnati to test the air currents going west and east. So the idea was he'd go east to the seaboard, the eastern seaboard, and then head west and head back to his original location in Cincinnati, which is kind of a central location. Um, so he did. Low built a balloon called the Enterprise with the backing from Joseph Henry. This was a 30,000 cubic foot coal gas filled balloon with a payload, which was a steam lifeboat designed by John Erickson, who also designed the USS Monitor. So there were a lot of prominent people involved in this technology. Now, on a test flight, April 19th, 1961, note the date. Low flew from Cincinnati to observe Confederate troop movements, and he traveled a total of about 650 miles in 9 hours. And during this trip, ironically over Virginia, he heard about secession of South Carolina, but now the winds took him to the Carolinas. How ironic is that? Where he's forced to reascend by armed men. So he did, and he landed again in South Carolina, where they escorted him to Unionville. This was the northern part of South Carolina. And he, of course, he was jailed as a spy. Fortunately, so up to this point, Low had some disfortune, but now this Mayor Boatwright of Unionville recognized Low, gave him a passport out as a gentleman of integrity and high scientific achievement. So he knew of his work. He knew what he was doing. He was only a civilian. So he gave him a ticket back home. So he took a train back to Cincinnati, and he ended up where he started, fortunately. Here was his route. So you can see he started in Cincinnati, and of course, Virginia was all one. West Virginia was part of Virginia back then. He went all the way south of Richmond, all the way to the eastern seaboard, and turned back. But by that time, the winds had taken him south, and that's why he ended up in Unionville. Now, now we're at the Civil War period. The innovations in the Civil War, we're all familiar with the first: artillery and cannonball developments, machine guns, railroads, telegraph, and so forth. But one thing you can ask your history friends who are familiar with history, maybe not as much Civil War history, when was the first aircraft carrier used? They'll probably tell you it was World War II because they were extensively used then, but no, the answer is they were first used in the Civil War. There's another Civil War first. So boats carrying balloons became the first aircraft carriers. They took an old coal barge and just cleared it off. It was the George Washington Parke Custis. And they cleared it off, and I'll show you a picture of it in a minute. And they put all of Low's machinery to develop the gas that he needed, and the balloon and his team and everything else. And that could be gone down the river, any kind of river you want, and the balloon could be transported anywhere it's needed to observe a battle. So Low sent the first telegraph message from a balloon to Lincoln on the Enterprise in 1861 over DC, and that was that picture I showed you earlier. The Union of Bull Run used a balloon as well in July 61, but unfortunately it was ripped apart by trees. So these are some of the problems that did occur in ballooning. Here's the first aircraft carrier, George Washington Parke Custis, and you could see where the equipment is over here to create the gas. You had the team around here. It was a tethered balloon. Nevertheless, you can see it could go quite high and observe quite a bit while being transported. Here is a copy of the letter that was sent to Lincoln, telegraph. There was a telegraph machine, it was a tethered balloon, so they had the ability to have a telegraph line there. And I won't read the whole thing, but the excerpt from it: "We command an extent of country nearly 50 miles in diameter. The city with its girdle of encampments presents a superb scene." And that was the picture I showed earlier. So you could see you didn't have to get very high in order to have a beautiful view of the whole area. So General McClellan, he was an innovator, if nothing else, but he supported Lowe. He realized the potential in balloons, and Lowe had already developed the system to um, create the gas needed for the balloons that can be transported. All of these trailers that he used could be transported easily. So in August of '61, the first reconnaissance mission by Lowe was near DC, near Fort Cochrane, and he had actually observed Confederate troops, Clark and Musson's Hills. And of course, this was the first chance that the Confederates had to fire upon him, but he was not hit. As I said before, very, very small moving target there. He used his portable gas generator. He observed artillery tests. He guided the testing of accuracy from his balloon, which was a first. And of course, this demoralized the Confederate troops because they were being spied on and they couldn't do much about it at the time. On September of that year, McClellan ascended with Lowe, which was a first time a military man had ascended in a balloon. So he continued to work with McClellan and Fitzjohn Porter, where he obtained 2 new balloons. So he was starting to build up the arsenal for the balloon corps. He used copper lines, a hydrogen carrying hose made by Goodyear, and a filter at the end. So he involved industry and everything. This was a joint project between industry, the military, and of course, science. Here's a picture of his equipment. Notice there's only 2 trailers here. They have an intermediate where the gases were collected and then fed into the balloon. And of course, he claimed that a typical balloon could be inflated in about 3 hours. So it took a while, but at least it's portable and it works. So uninflated balloons, you want to tow an uninflated balloon because otherwise the wind could just carry it away. In fact, that happened whenever they tried it. So you could use wagon, trains, boats, coal barges. So there are any number of ways that you can get from one location to another as needed in order to get your observation where you needed it. Of course, McClellan, supporting this, approved the request for new balloons, 5 total, and a pilot. So William Paulin, I mentioned before, was one of the first pilots in the balloon corps. So by December of that year, 6 balloons and the renovated Union were commissioned. Now, here's where the personal stuff comes in. Lowe had competitors. Everybody tried to vie for being the head of the balloon corps so they could run the balloon corps and dictate what goes on during the balloon's ascensions and so forth. His main competitors were John Wise, James Allen, and John LeMountain. Allen himself didn't have success. His gas generator was fairly unreliable, and this is where Lowe really had an advantage in generating the air needed. So he tried to inflate his balloon with city gas, and of course it burst because you can't control that as much as you can when you have machines there. Later, a larger balloon was inflated, and while the 60 men were towing it to Falls Church, a gust of wind took it, and of course the telegraph pole destroyed it. So exit Allen, one gone. There is a portrait of Allen a little bit later in life, but he was volunteering his services to the Union Army. John Wise, unfortunately, knew a lot about ballooning, had studied it, but he had similar experiences. I guess in scientific terms, he's more of a theorist than experimentalist. In Manassas, troops carrying the balloon were way too slow to avoid trees, so it was put on a horse-drawn wagon. This pace was too fast, and the winds put the balloon into the trees anyway. Wise repaired that balloon, but subsequently telegraph wires tore the cables, and the balloon sailed away, landed somewhere in New York. So exit Wise. The Mountain criticized Low for tethered runs, and he said, "Oh, I want free runs," and so forth. So he proposed that Union troops should be in a particular location so the free balloon flights could be made. You know, you position your troops because of a balloon flight? No, I don't think that'll work. This is very limiting factor, and of course, the lack of communication hurt his chances for becoming the head. So his balloon, the Saratoga, was lost in a wind. His Atlantic balloon was seriously aging, very unreliable, and he didn't really have the money to replace it. So McClellan was really irritated about this whole feud, and he said, "You know what? A Mountain, you're dismissed from service." So exile a Mountain, and who's left but Low, our main character. Balloons in Low's Corps included the Constitution, Intrepid, Union, Enterprise, Washington, the United States, and the Eagle. So there were two at 15,000 cubic feet, one at 20, two at 25, and two at 32. So he had a wide variety of balloons available. And the smaller ones were easy to fill. So for quick jobs, that was good. Also useful in the winter because you didn't have the weather to fill it, take 3 hours to fill it and so forth. So use the smaller ones for that. There were only 6 that were commissioned. The 7th was in reserve. So these were used for observation and communication. They were very effective, as I'll point out when I list some of the battles they were used in. Another first for the Civil War, the balloons led to the first military blackout. General Beauregard saw balloons spying, so all fires were put out. What they did, the other thing they did is they took logs and made them look like they were artillery to throw off the observations and so forth. Another first, Arthur Lumley did the first aerial sketch in 1762 during the siege of Yorktown in a flight with Low. That was also a first. And of course, during this siege, Low used the Intrepid and the Constitution. There's a picture of the Intrepid being filled. And there's a picture of Low, actually, a photograph of Low going up in a balloon, in the Intrepid, for that matter. And so here's Low's team. So he was the head of Balloon Corps, and he had a team of William Pollen, Jock Starkweather, Ebenezer Mason, Ebenezer Seaver, James and Ezra Allen, brothers, and Jacob Freno, and John Steiner. So he had a pretty good crew there. They were all trained quite well. The unfortunate thing is Pollen had a career as a typist, so that took too much time as away, and so Low dismissed him. Mason and Seaver were owed back pay. They refused to fly after a while. Freno went AWOL to run a gambling operation. I guess it was more lucrative. Steiner could not get adequate support from Halleck in the West, in Illinois, so he returned to the Army of the Potomac. So ballooning on the Western Front was basically non-existent. So it only existed typically in the Eastern Front. Here's Seaver and Starkweather, 2 of the balloonists in the team. So here were some of the battles that the balloons were used in. Camp Allegheny in West Virginia, what's now West Virginia. First Low balloon flight in battle. Of course, he was fired at again, none hit. A Parrott gun can only reach a height of 400 meters, but the target is 2,000 meters away. So even Parrott guns couldn't hit it. And I quote there about a degree. It's actually a little bit less than a degree, and it's moving. So Yorktown in spring of '62, 300 meter is plenty of height. He kept an eye on Confederate troops, and he didn't have to be real high because he only had to see where the extent of the troops were. So again, 300 meters is about 1,000 feet, a little less, and so he didn't have to be very high. Here's the position in Yorktown. You got the James River on the left here, and the York Potomac. Here's where the balloon was, right in the middle. So it really covered. Yorktown is up here, right up here, and so you could really see this whole area, both rivers, this whole region around here. You could see from 300 meters. And this is a sketch, again, of the Confederate camps that were observed with the balloon. So you can see them scattered all over the place. You can see troop movements. I mean, you move even a regiment, you're going to see it from a balloon. Fitzjohn Porter ascended over Virginia without an aeronaut. I don't know why he did that. And of course, the tether broke, so he went into free flight and he drifted for a long time. And of course, he drew enemy fire, not hit. He finally gained control again, landed very roughly, hurting his side. So he never tried that on his own again. Makes sense. Some other battles: Battle of Seven Pines, Fair Oaks in '62. His observations actually prevented a Union regiment from being cornered and decimated. He was able to warn them where the troops were, the Confederate troops were, and they avoided that. Gainesville, Chickahominy, Mechanicsville, Virginia. Uh, Actually, this is the first time observation balloons from both sides flew. The Confederate balloon was eventually caught, however, after a couple of observations. Unfortunately, they didn't use it. I'll talk a little bit about theirs in a minute. Battle of Malvern Hill in Richmond, balloons helped in very hilly terrain because they could see above the hills and on the other side, so they could warn the troops about where the troops were. Here's another view of the Intrepid being filled. Let me talk a little bit about the Confederate balloon corps. Captain Bryan flew a balloon, used varnished cotton over Yorktown, but unfortunately, they didn't have the idea down of how to keep it from rotating, so that hindered observations. Didn't have the greatest luck with that. A second flight was hindered by a man getting tangled in a tether. So they cut the tether, and of course, then the balloon sailed in free flight. And he landed near the York River, near Williamsburg, on the other side of the river. Lee ordered a silk balloon to be built from a factory. The myth of the silk dress balloon is probably a myth. They did use the silk that would have been used for just making dresses, though, for making this balloon. So it's a factory type thing. It was the Gazelle. It was captured by the USS Monitor aboard the Teaser, which was a coal barge again that was stuck on a sandbar. So they captured that one. And by the fall of '62, Confederate balloon observations really ceased. So they really didn't have a chance. They didn't have the equipment. They didn't have the trained balloonists that the North did. So they decided to cease it, not spend too much money on developing it. The last battle where balloons played a major role in a civil war was in the Battle of Fredericksburg. They provided valuable info at Mary's Heights. It didn't help a lot, but nevertheless, at least they provided enough information that it might have saved some lives of the Union in Fredericksburg. There was a balloon observation in 1863 by Ezra Allen, one of the balloonists, and he talks about the ascension and so forth. Hey, this is justification. We should keep this thing going and all that. This is a service letter recommending that the balloon corps be maintained. And note it's June of 1863, just before Gettysburg. So it would have been useful there. So let's talk a little bit about successes and failures. Lowe did have considerable success with the Army of the Potomac. He observed, camped, moving troops, cavalry, artillery, and of course he sent the telegraphs warning their commanders about the battles. He was fired upon more times than any other man in the Civil War, never hit. And of course, the most dangerous times were taking off and landing because they were the closest to the ground. The only casualty, ironically, was a telegraph operator who stepped on a concealed torpedo at the base of a telegraph pole. This was the only casualty. And this was in part due to these experienced balloonists and Lowe being able to control everything, the technology, the operation, and so forth. There was a mishap. There was an artillery shell that was aimed at Lowe. It hit a cesspool and covered this poor army guy with debris, as you might guess. And of course, his clothes and appetite were utterly ruined by this. So that was another mishap. But again, the guy lived after cleaning up. But here's where the political struggles came in. Crew training was difficult. It took A lot of training to get the balloonists, the experienced balloonists, enough to be able to handle the balloons. One uh, captain, 50 enlisted men was the crew, and they did not accompany balloons. So you had to have new crews in each locations because they didn't want to transport 50 enlisted men just to follow the balloon. The aeronauts were civilians, so were at risk of being caught as spies. And that was part of the problem. The biggest problem was the bureaucratic control, because the balloon corps shifted from topological engineers to quartermasters to corps of engineers to signal corps. I guess in some way each was appropriate, but it just didn't stay put. And that was part of the problem. In January of 1863, now this was after Fredericksburg, Hooker became the general of the Army of the Potomac, and he put Captain Cyrus Comstock in charge of the Balloon Corps, military head. And he favored the balloons being under entire control of the military, which was a problem. You had training problems because all of your experienced balloonists were civilians. You had logistics problems. They just weren't trained in aeronautics. They didn't know what they were doing. Here's Porter Alexander. He flew the Confederate Army's so-called silk dress balloon. He was later, of course, famous for Gettysburg, the artillery colonel there. And this is Captain Comstock, who took over in the Balloon Corps. Just a little what they look like. So Comstock, Congress was asked to justify the $200 a day it took to run the balloons, the 40 horses, 30 men, 7 wagons. So he wanted Lowe to cut his staff in order to be able to cut the funding and get it through Congress. All take reduce pay, adhere to new rules, more paperwork, record completed inventories. And Lowe says, look, I've been successful at this. I don't need this stuff. So he really thought he had served the military well. And so because he couldn't get funding, he couldn't get support, and all these restrictions and everything, in April of 63, he resigned. Now, this was before Chancellorsville, before Gettysburg, some of the places where it could really have been useful. So he thought the service at Marye's Heights would justify keeping up of the Balloon Corps, but not in Comstock's mind. So he ceased balloon operations on May 6th. Again, note that date. So James and Ezra Allen remained as the sole members of the Balloon Corps, but now you're starting to see the balloons aging. They'd been up and down quite a bit. They weren't redone at all, upgraded. So the last recorded observation was near Fredericksburg in 63, noting Confederate troop movements toward Gettysburg. So after the summer, this is the aftermath. Now, the Balloon Corps, Civil War still going on, got another half to go. But the Balloon Corps now has no longer existed. They weren't officially used, and the team had disbanded. LaMountain flew for a while, but he died in 1878, so it didn't last. Pullen took up photography full time. Wise took off later in 1879 with George Burr from Illinois. They were never seen again, although Burr's body was found near Lake Michigan. Wise was never found. The Allens themselves flew reconnaissance missions for Brazil and continued flying into the 20th century, but not in a military view. Lowe himself stopped flying in 1866, right after the Civil War. He was disgusted by this. So he continued inventing, however. He invented coke ovens or furnaces. He built an astronomical observatory in Pasadena. So he was still active, but not with balloons. However, in the meantime, Count Zeppelin had visited America during 1863, and he had seen Lowe's balloons. He actually flew a balloon ride in St. Paul, Minnesota. So he was quite influenced. And of course, we know later on in the century, in the early part of the 20th century, the Zeppelin, Graf Zeppelins and the dirigibles were developed, and he was quite influenced by Lowe in that. Unfortunately, Lowe died impoverished in 1913. So, ballooning in the Civil War, as we've seen here, is a mixture of successes and failures. The core demise, of course, appeared to be largely administrative, personnel problems and bureaucratic problems and so forth. Logistics, cost, personal differences, mixed successes were all factors in this decision. However, the good news is that a lot was learned about using the air in warfare during the Civil War. So in the 20th century, the airplane all but erased all these disadvantages. They were highly maneuverable. They were powered by readily available fuel capable of landing accurately for the most part. And of course, they were still susceptible to weather, but not as much. They were a little more control. A light rain they could probably handle, unlike balloons. So most of the disadvantages of the balloon corps during the Civil War were not there during World War II, or World War I or II for that matter. So this was a spur to go on and use airplanes and so forth for military. Now, in the military, interestingly enough, during the World War I, they were not only used for observations, but for bombings and for fighting each other. Air warfare had gotten so popular and so used in military that they were fighting each other. So this is really the beginning of today's Air Force, but from the lessons we learned during the Civil War. And of course, World War II saw some really great advances in technology. They created the Air Force in 1946 as an outgrowth from the Air Corps. And of course, today's Air Force is extremely advanced, most powerful in the world, but it all started with the development of the balloon. So I thank you, and I'm willing to entertain any questions that you have.
Thank you, Gordon. Angela, you want to start on that end with questions from people in the audience? And remember, as a reminder, those online, if you have questions, just submit them in the chat function.
Anybody got any questions? Just come on up. Anyone? Bueller? No one?
Yes.
Anybody got any questions?
Yes, go ahead.
Got a quick question. Where did the hydrogen come from?
Purely chemical reactions. As I mentioned, Jacques Charles mixed iron sulfate or iron and water, and it created hydrogen gas from that. So it was all chemical reactions. There were various chemical reactions that could create that, depending on which chemicals were available at the place and time that they had. But it was all chemical reactions that generated that.
There, you got a question? Come on. So the people at home. Sorry.
Maybe I didn't catch it, but why were military soldiers, why did they not fly the balloons? Why was it civilians?
Because the civilians were trained. It took a lot of training to really get the control of the balloons down, both the ascension and descent, and just if they were in free flight at all, just being able to control where they were. And the military just weren't trained in that sort of thing. Nothing like that was in the training in West Point or VMI or anything like that. So it was the military, the civilians that had been trained prior to the Civil War that were the experts at flying. And so that's primarily why.
Gordon, we have an online question.
Sure.
One of the participants wanted to know if any of them, I guess the aeronauts, north or south, ever tried to drop bombs from any of the balloons.
Not that I've ever read. Typically, they didn't want to go directly overhead because then they might be a little bit easier target. And that was, of course, what would be required to drop the bombs. So they were strictly used for observation and communication, as far as I know.
Okay. We have a second question online. After airplanes came into common use, particularly in the military, when did balloons get used in combat? by American forces. I guess they're talking about
During the 20th century?
World War II.
Yeah. As far as I know, there was no widespread use of balloons. Um, Remember, most of the battles were overseas in both wars, so there wasn't a chance to bring balloons into play over there. I suppose they could have used French balloons or English balloons and so forth, but by that time, air reconnaissance had gotten so sophisticated, even in World War One, that they really didn't need balloons on a large scale for any kind of observations.
David?
Just curious, you said they used telegraphs to communicate from the balloon,
Yeah, that was during tethered balloon flights.
so they had to pull the electrical wire.
Yes,
That would be heavy, would it not?
it probably would. It was cable, telegraph cable. Nevertheless, not heavy enough to bring the balloon down. In other words, with only one or two people and even the heavy wire, you still had plenty of air in the balloon to keep it aloft. So yeah, they had them in there. They were able to do that.
Gordon, we have another question. Are you familiar with a British aeronaut named Edmund Reed?
I've heard the name, but I don't know his work or anything like that.
Anybody else? Who manufactured these balloons for the North? Were they contracted? Manufactured the balloons.
Yeah, they were. They had locations where they made them. They put them together and so forth. I think Lowe had. He was able to observe a lot of the manufacture to make sure that the techniques were right and everything. He was the expert. But yeah, they were manufactured at certain locations and then transported to wherever they were needed. And it was mostly, as I said, it was mostly out east.
Anybody else? Last call.
Gordon, you might be, and you may already know this, but you referenced the myth about the Confederate balloons being sewn from women's dresses. And that was taken directly from a newspaper interview with James Longstreet.
Yeah.
No one at the time could figure out why he said that. Even Porter Alexander, who operated some of the balloons that you talked about also,
Right.
said, I don't know what Longstreet was talking about. And during the course of my research for my most recent book on the war in Georgia, and you referenced this too about the silk that was ordered to manufacture the Confederate balloons.
Right.
And I found a receipt from where the silk was manufactured and shipped to the Army of Northern Virginia, and the silk was manufactured in Savannah.
I'll be right there in Georgia.
Wow.
So Longstreet, I don't know. And he was in Georgia when he said that.
Yeah, well.
About the women's dresses. I don't know if he was just trying to make a joke.
Yeah, publicity, right?
You know, misquoted, I guess, or fake news, as he was.
Fake news, yeah, there you go.
But it's a funny story.
Oh, yeah. Oh, my gosh.
Okay, Michael, we are good here. You got any questions online?
No, let me just check one more time. I believe we got all of them. No, that's it. That's all the questions online.
Very good. Well, thank you all for your attention. Appreciate it.
Thank you, Gordon. Very much. Well, I'm going to turn it back over to Angela, I guess, for the rest of the proceedings at the Hilton, and everyone have a safe trip home, and we will see you in March. Our speaker will be Gordon Ray, and two Gordons back to back.
Yeah, wow, awesome.
It just struck me now. Gordon Ray has done a lot of phenomenal work on the Wilderness Campaign in Virginia of 1864, which was playing out at the same time as the Atlanta Campaign here in Georgia. So hopefully, as Terry mentioned earlier, invite your friends, encourage him to come to the meeting, and I think you'll be in. We're very fortunate to be able to get Gordon to join us, and his weather conditions are allowing him to travel to be with us in Marietta. So we certainly look forward to that, and we'll have another great program like we have this evening. So again, Gordon, thank you very much.
Okay, I do see Tim Tidwell's hand up in the Zoom here. You see that? Let me hang on.
I do, but I don't see Tim. If you have a question, just send it in chat. I can't unmute anybody,
Okay,
unfortunately.
right.
But if you have a question, Tim, just send it in chat, and I'll relay it to Gordon. Maybe he was waving goodbye.
Oh, well, okay. Yeah, that could be. I don't see anything in chat. So otherwise, Tim, if you just email Michael and he can email a question, I'll happy to answer it over email.
Thank you, Gordon.
Okay, I'm going to end this. I'm going to end the Zoom session if that's okay.
Yes, thanks for joining us.
Okay,
Stay
you
safe.
bet. Thank you for having me.
Yes, sir.